Hello everyone, welcome to the session Fundamentals of C and Programming. In this short video, let us extend the concept of Endianness and understand how the CPU accesses multi-byte value using a basic 5-stage CPU pipeline. Here, consider this block of memory where the multi-byte value is stored in little Endian byte ordering format. Whereas in this block of memory, the multi-byte value is stored in big Endian byte ordering format. Consider we are using load and store CPU architecture where some set of instructions are generated by the compiler. Here we are using a pseudo instructions for convenience. In this example, load instruction loads the value from the memory location into the CPU register R0. Add instruction will add the value within R0 register with the other operand value, and the result is stored in the R1 register. Store instruction will update the value within the R1 register into the subsequent memory location. Here, each and every instruction has to undergo the stages of CPU pipeline. For example, CPU fetches the load instruction from the instruction cache. In the next stage, instruction is decoded where the values of the operands are read from the register file. In the execution stage, the absolute value is calculated from the value within the base address register with the offset value. In the memory access stage, load and store unit will request to the cache controller to fetch the value from the requested address. Cache controller will look up the cache for the requested address. In case if there is a cache miss, then cache controller forwards the request across DDR controller through AXI interface. DDR controller looks up for the address in the memory. In case if the address is found, then the value is sent to load and store unit where the multi-byte value is byte assembled as per the byte order and sent it back across write back stage. In this stage, the value is updated in the destination register where the most significant byte, irrespective of whether it is little Endian or big Endian, it is stored in the higher bit fields of the CPU register, whereas the least significant byte is always stored in the lower bit fields of the CPU register. In this way, store instruction will also go through the stages of CPU pipeline. For example, instruction is fetched, decoded and executed where the absolute address is calculated, and in memory access stage, load and store unit will request for the address to cache controller. Cache controller will look up for the address within the cache. If there is a cache hit, then load and store unit will byte assemble the value as per the byte order, whether it is little Endian or big Endian, before storing it into the memory location.